So let's now talk about how you're going to create internal threads in several of your parts for the steam engine. So what we'll talk about now is the upright part. The upright part, you have already drilled the two holes in the end of the upright, which we're going to connect to the base part. So these two holes have already been center drilled and drilled. Now, how do you know what drill size to use prior to tapping the threads? So you have to use your tap and drill card. Now, if you can see from the drawing that for the upright, these two holes are going to have 10-32 threads. So you find 1032 on the tap and drill card, and then you go straight to the left, and it tells you that you're going to use a number 21 drill, which has a diameter of 0.159. So then you'd have to find a 21 drill, make sure you really have a 21 drill, and determine the appropriate center drill. So this part has already been center drilled and drilled on the drill press. So now we're going to tap by hand on this one. This is one of our tapping methods. So we'll just go ahead and mount this upright in the vise. Hopefully you can see that. Alright, and so now what we're going to do is the tool that we're going to use is called a tap. So it has threads on the tool plus flutes in between the threads so the chips have a place to go when you're actually cutting the threads. We're going to use two different taps today. One is called a plug tap, which has a taper at the front, at the end of it, so that as it gets started it has an easier chance of getting started and helps you to line up the tap as you go. We're going to use the tap connected to a tap, what's called a tap handle. So what you're going to do is push the tap in as far as you can by hand, and then we'll just use pliers just to tighten that down so the tap doesn't come loose in the handle while you're tapping. We will use a drop of oil on the end of the tap. And then you're going to do all this by hand, so alignment is very important. The threads can be tapped crooked even though you've already pre-drilled the hole. So at the beginning you just want to use a little bit of downward pressure just to get the tap to bite into the part like this. Give it a couple of turns so it can stand up on its own. Now what you're going to do is you're going to inspect the lineup. You're going to look from two different directions and see that the tap is lined up with the hole. At this point you can correct that. So it looks like, for me, it looks like the tap is maybe leaning a little bit back that way. So as I take a few more turns, I'll try to correct that while keeping it still lined up in both directions. Okay, then I'll again inspect it. It looks like the alignment is pretty good in these directions. So now what I'm going to do is I'll start cutting the threads, continuing to correct the alignment. Once you get going here a little bit, then the tap will stay straight. Okay, so the method is now that you're going to go forward a half a turn and then back a quarter turn. And when you go backwards a quarter turn, you'll be able to hear the chips breaking up. So it's mostly for the purpose of breaking the chips. And you'll actually hear the chips breaking as you go backwards. Because this plug tap is tapered, it will not reach all the way down to the bottom of your blind hole. We drilled about 6/10 down. So once we get down as far as we can go with this tap, then we'll change over to the bottoming tap, which has a flat bottom and can get down a little bit farther into this blind hole. So forward a half, back a quarter. I can stop here and just verify I still have really good alignment in both directions. Going to come a point here where I'm going to start getting some big resistance, and as soon as you get a lot of resistance and it doesn't feel like you can tap the threads anymore, you have to stop and unwind the tap. I think I'm right there now. If you go beyond that point and force it, you could break the tap off in the hole. You're going to get some twisting of the tap, and at some point it would break. So you just unwind it now just like you would unwind a screw. And you'll see the tap is dragging out a lot of chips with it, which is a good thing. And we'll take a brush and brush those chips off. And now next we're going to use a bottoming tap. Flat bottom. It will already just screw into the hole because we've already created threads. And before I do that, let me just put another drop of oil on there. And this should just pretty easily just screw right in. And then this will allow you to get down a little bit closer to the bottom of that blind hole so you have threads a little bit further into the hole. Alright, so now I'm going to start, I'm getting some resistance, so I can go back to my method of half turn forward, quarter turn back. And then, once again, you'll get some big resistance that says you're really at the bottom of the hole and you can't go any farther. It's right there. Okay, so unwind this. This tap will also drag a few chips out. For inspection purposes, the only thing we're going to do is to take one of the 1032 screws that came with your engine, and we're just going to make sure the threads work. So again, that tap pulled a lot of chips out. Brush those off. So we have the 1032 screw, and then also you have the hex key, and then you can just test the threads, make sure that they work okay. That one looks fine. This steel screw also serves to maybe clean up the threads a little bit. So on your inspection report, you'll just report that the threads worked okay. All right. So that's hand tapping. Again, the alignment is the most important thing here. So here's another tapping method that we will use often when we have the opportunity, and that is to use the milling machine for tapping, but we're going to use the milling machine as merely an alignment tool, and the machine will be off and not running. So we'll have the machine off, speed all the way down. We can even reach up and even turn the power off on the power strip just to make sure that it doesn't start up on us accidentally. So here's how we're going to do it. So on the table right now I have the upright, and hole number 1 has already been drilled. You can see from your upright drawing this hole was center drilled, and then an 1/8 inch drill through, and then there's going to be 1032 threads a 1/4 inch deep, so that the air fitting can screw into that hole. That'll be your air intake for the engine. So the way we're going to use the milling machine for alignment is the first thing we're going to do is we're going to use what's called a center. It has a taper that matches the taper inside the spindle. So we're just going to push that up into the spindle like that, and then the point of the taper is going to fit inside the hole on the end of the tap handle. So we have the tap handle. One of them does, one of them doesn't. This one actually, the hole in the end actually has a countersink that fits very nicely into the center. So tapping will be the same as always. Put a drop of oil on the bottom of the tap, place the tap into your pre-drilled hole. So the hole was drilled a 1/4 inch deep with a 21 drill, which is the tap drill for 1032. Then we're just going to use the Z hand wheel to bring the center down into the end of the tap handle. And then you can proceed from there. So this is the tapered plug tap. Just going to get it started. And as you tap down, you'll occasionally have to reach up and just lower the Z-axis to keep the center in the end of the tap handle for alignment. Now you don't want to bring it down too hard and start driving the tap down into the part. You just want it to fit into the end so that the tap handle stays aligned. So once I have it started, go again forward 1/2, back 1/4, and then every now and then reach up and bring your Z-axis down. And once again, at some point you're going to get some resistance because the number 21 drill was only drilled down a 1/4 inch. So at some point you're going to hit that 1/8 inch hole, which will make it sort of look like a blind hole. Not exactly, but sort of like a blind hole. Now this is only going a 1/4 inch deep, and this is a 1032. If the hole was 1 inch deep, you'd have 32 threads, but it's only a 1/4 inch deep. So you're only making a total of 8 threads. So this doesn't take long. I think I just hit some resistance there, so I'm going to raise the Z-axis, and then we'll just unwind this plug tab. Be careful taking the tap out so you're not inadvertently causing any damage to the threads. Then we'll put the bottom tap in, a little drop of oil, so we can screw in the bottoming tap. Again, you can bring the center down into the end of the tap handle for alignment, and you probably will only get another 1 or 2 threads at the most, I would think. Okay, and that's about it. You can feel the heavy resistance when you hit that 1/8 inch drill through hole. And then after you finish tapping with the bottom tap, then you can just test it with one of these air fittings. Sorry for the delay here. So we'll take an air fitting that came with your kit, and then you can just test it just by screwing that in like that. So that's it. So that shows you how to use the milling machine as an alignment tool. So the third method we'll use for tapping internal threads is using a tapping machine. So here's our large tapping machine. We also have a smaller one, which we don't use much, but it is available to you for using tapping smaller sizes. we could use that when the milling machine's either not available or the setup isn't quite right. So this tapping machine comes with a number of collets. So you can see here's the collet we'll use in this demonstration. So the tap handle, the tap fits into this collet, and there's a set screw to tighten it down. And then you'll notice here on the front of the machine, so here are the handles you'll use for tapping, and they're pretty large, so you can there's no problem in terms of the force that you have to apply for tapping. Okay, and then this handle comes all the way out like this, and so then the collet and the tap end up fitting in the end of the machine like this. The collet's hex, and there's a hex in the bottom. Okay, and then there's also a hole in the plate, so as you're tapping, for instance, if you were tapping a through hole, then there's a place for the chips to drop through as you're tapping. And as you're tapping, you're going to use the same method that you use in terms of half a turn forward, quarter turn back. Okay. Now, one thing that's very important that I want to cover is this collet, again, will fit into the machine like this. And there is a set screw on the side of the collet. You have to make sure that you tighten that down. You could tap without tightening it down, but the problem is if you don't tighten it down so that the tap and the collet are connected, we might never get the collet out of the bottom. You'll be able to pull the tap out, but then the collet will be stuck in there, and it's quite difficult to get it out. So set screw is extremely important there. So we have our quarter 28 tap into the quarter-inch collet. The reason the machine has so many different collets is to fit a variety of taps. So we have the tap in the collet, set screw tightened down so that they're connected. Now we're going to use, for our engine project, we're going to use this tapping machine for the flywheel. There are quarter 28 threads in the middle of the flywheel. So we'll place the flywheel down on the table of the tapping machine. Then you can just place the collet up into the end of the machine, and then just come straight down so that the tap is aligned up with the hole in the flywheel. Now you might want to use a clamp to make sure that the flywheel doesn't move around. So we have a long throat clamp that you can place over it. Now you might end up marking up the flywheel, so you can use something like, here's like a little piece of emery cloth. You could place that over the flywheel just so you're not marring up the flywheel as you're tapping. Okay, so now that you have that, then you would put a drop of oil on your tap, and then you just tap as before, and your tap will stay lined up. Chips will fall down through that hole. So that's it for the tapping machine.